Today, let us discuss about the interference of light. The basic concept is regarding interference. Here, we discuss about the interference of light. Now, the phenomenon of interference has proved the validity for the existence of wave theory of light. So the phenomenon of interference has proved the validity of wave theory of light. This was indeed, the wave theory of light was indeed explained by Huygens. Now, let us get through with the introduction part regarding interference. From our previous studies, we know that we concentrated upon light, and according to Newton's corpuscular theory, light is supposed to be more often studied in terms of a particle. Now we deal with light in terms of wave. So we say that the wave theory, according to the wave theory of light, interference is the existing what we call it as the pattern or the phenomenon which clearly explains about the different intensities possessed by the light. So how they get concentrated upon and how they evolve. All these respective factors have been clearly done with respect to the Huygens wave theory of light. Now, the basis for interference of light is the superposition principle. The superposition principle is stated as follows. It says that when two or more waves superimpose with respect to one another in a particular medium, then the resultant displacement of at any point in that particular medium is equal to the algebraic sum of the displacements of the individual waves. Now, we write it as here in terms of when two waves now the interference pattern is what we see here. So this is, consider that this is one particular medium in which the wave is supposed to be propagating. There is one more wave. Here, let us consider that this is one more wave. Now, if these two waves are passed through a single medium, they get superposed with respect to one another, like this. Now, this is how the pattern can be formed over here. Okay, these are the crests and troughs respectively. If we consider at one particular point, the displacement means from here to here. Now from here to here, these are the points where they are getting displaced from their initial position. So if I consider the resultant displacement as capital Y, then for each and every individual wave at their respective points, if we consider the displacements as y1, y2, y3 respectively, then we write it as y is equal to y1 plus y2 plus y3 plus and so on, etc. So this is how we give the mathematical expression to explain about the resultant displacement made by a particular wave which is passing through a single medium. And y1, y2, y3 are the individual displacements. So this is how we state for the displacements of the respective waves. So this is what we call it as the superposition principle. So in what way is it connected with the interferences? Here the two waves are supposed to be interfering at one particular region. And in that particular region, we are concentrating on the displacement of the particles. So even though they are getting displaced at each and every respective point, they are getting interfered with one another. So that is the basis for the interference pattern. Here also we say that when two waves are supposed to be superimposed with respect to one another in a particular region which possess same frequency, same wavelength with respect to certain amount of phase difference, we say that those waves are supposed to be in interference with respect to one another. According to the phenomenon of interference, when two waves are supposed to be superimposed with respect to each other, we call that as superposition region as crossover region. Crossover means when they cross with respect to one another, we generally refer it as the interference pattern. So this is the criteria how the interference pattern is evolved in terms of explanation in terms of two waves. Now why we definitely take only two waves is that for that interference pattern to take place in a particular medium, so two waves they get superposed in a respective region and then evolve the different types of interference which we will be discussing later. So to evolve that kind of a thing we require two sources. Normally it might be a point source or a narrow source or an illuminated source, you can call it in any way. So that is the basis for the interference pattern. Now, as far as the actual definition is concerned, we say that the modification in the distribution of intensity, in the region of superposition is known as interference. So the intensity gets distributed within that respective region, which we call it as the crossover region or the superposition region. You can say it in either way. So this is according to the definition of interference. Now, what are the conditions for interference? So when do we say that the waves are, what is the criteria that how the waves are going to be interfering with respect to one another? So regarding that we have few steps. The first case is we require two sources. The first criteria for the interference pattern to take place is we require two sources. We can call it as two light sources as well. The second condition is this interference pattern is generally taking place in a darker region. That is the background where this interference pattern is generally evident is where we make use of a darker kind of a background. Next, we bother about here the placement, that is with respect to the medium. A necessary medium is required for the propagation of the two waves. It may be either a transparent medium or an opaque medium. So the surface which we use should be opaque to light. Of course, these are the main criteria for the interference pattern to be taking place.